This is the Amp Hour Podcast. Released June 14th, 2020. Episode 496. Drab Olive.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
You had to go and start, didn't you? You had to ask, which is more important?
Oh, the tweet.
Which is the more important skill was it engineering in general or was it electronics?
Yeah, it was engineering.
Engineering in general. Which is the more important skill, folks? Chris's two options are intelligence or determination. That's all you
some
gave
of this,
us.
Dave, is meant to be. It was meant to be provocative. Actually, so that there is a story behind it. It was.
So you were trolling?
No, there's a story. So I.
Right. Okay. There's always context.
Yeah, I was asking about, because it was for my nephews, and we were so I was talking with my mom. You know, she's their grandmother, the kid's grandmother, and we were just talking about like the role of, you know, like those studies that say you shouldn't tell a kid they're so smart. You should tell them that they try hard. They tried hard. Have you heard about that research?
Not really. No.
Okay. I don't have any references to this because Dave popped this on me. I didn't know what he was going to say.
Right. Okay. I did. Sorry.
Yeah. But yeah, there are studies out there that, you know, basically say it becomes an identity thing of like, oh, I'm so smart. And that it's not that it's an innate being thing, like that I am a smart person. So that then if you fail, I felt this myself. Like if you fail, then you feel like, oh, I am a dumb person. Mm-hmm. The better message is usually more along the lines of, you know, you didn't put in the time, or you didn't try that hard on this, this test or whatever, whatever the outcome was. And so there's some research around like encouraging kids through doing that. And so that was really the genesis of that question. And, you know, it was provocative, and, you know, people over the internet did or did not like that. And I fall on the, you know, like everyone's like, why not both? And of course, both, you know,
of course. I mean,
it's more of like a, you know, it was more like a, if you have both, which one is more important? And I think persistence is more important, assuming you have both. So.
Yes, but of course, you've got to have both. You can't just have, because my response to that was that
persistence alone is not it. Yeah.
Where you use the word determination, so
sorry. Oh, well, let's be official here.
Determination. I think it was determination. Anyway,
it was.
Right. So I went, if you just have determination, that leads to U-beam and solar roadways. Right.
Yeah, I think that's true. And
because you didn't have the intelligence to realize what you were doing, or the path you were going on was just dumb. You should, like think about it. Right.
Yeah.
You know, it's just not very practical. Right.
You dug this out of a while ago. I forget when it was, but there was someone who was talking about, there was like a really good analogy of like the determinations, like the gas in the car, and intelligence is actually knowing where to drive it, or something along those lines.
Right.
Like
okay.
That kind of thing. And it's important, right? You really,
of course.
You know, you know, if you know, and I think it's also comes down to like, you know, you could say intelligence versus, you know, earned wisdom, right? And like innate intelligence is, you know, I always think about like, you know, IQ and stuff like that. And like,
of course,
that alone doesn't, I mean, it'll get, you know, you're going to be bright, you're going to respond well, you might do well on testing, but does that mean that you're going to be as good at troubleshooting something on the bench where you really need to stick with it? Like that's when I think the determination really kind of kicks in.
Oh, of course.
But in the other direction, like you said, if you just stick with one thing, you just bang your head against the wall until you break through. It's like, sometimes, you know,
sometimes you needed to walk around the wall. Yeah, exactly. You should have just walked around, you know.
Yeah.
So
hence the provocative nature of the question.
The question, and yes, okay. I had to bring, because it is interesting, you know, who you know, who are the most, well, in engineering, right? In like, you know, science and physics, right? Intelligence is probably, you know, maybe like in pure research, for example, right? It might be intelligence that's, you know, the majority decider. Whereas in applied difference between theoretical physics might be mostly intelligence, but applied physics, for example, might be, a more combination of both. You've got to have the intelligence, but also you've got to have the determination to follow through on the practical, thing, and not give up every time the result doesn't go your way, and things like that.
Sure. I think some of it is like, I am not innately intelligent, but I like to think I'm determined in certain ways. So yeah,
right.
I favor determination.
Yes. Well, I know. What I was getting to was that engineering, right? When you have theoretical science, then you have practical science, and engineering is an applied science, right? You have to apply it. Engineering, you have to solve a problem. You have to build something. That's engineering. And engineering's not just coming up with a good idea. That is not engineering. Engineering's making it happen. So, I think which one of the groups, engineers make it happen was their slogan, I think it was Engineers Australia, maybe. I don't know. That's possibly where I got it from. Yeah. Anyway.
It was like a television campaign or something, or what?
It was like an online, media blitz kind of thing. Yeah. Engineers make it happen. And and that's really what it is. So if you don't have any determination whatsoever, you're screwed, right? You're really not going to be able to be an effective engineer. So, you might make a good engineering manager, perhaps. I don't know.
I don't know what makes a good engineering manager. I think it's, tolerance for pain.
Well, I mentioned tolerance for pain. I famously mentioned this many times before, and this will segue into another thing we've got on our Reddit list, by the way. There's, 5 universities here in Sydney that do engineering, right? And one of them, which is like our most prestigious, oldest sandstone building university here, which is the University of Sydney, right? They have a big engineering course. Right, it's like 1,000 people or something, 1,000 students or whatever.
Flagship university of the
it's a flagship. It's world renowned. Blah blah, and they've got a huge engineering program. But I don't believe, not once in my entire career, have I ever met or interviewed or seen a resume of an engineer from the University of Sydney. They just I don't know where all these engineers go. They all come from.
I bet I do. Nope, I know where they go.
Okay, tell me.
This is the thing. So for a long time, I didn't meet many like MIT engineers. I'm always like, where are they all going? And what the answer is, at least in the States, is I've met them since. But like I had the chance to go to MIT job fair when I was at Keithley, and it was very interesting because like seeing like who recruits.
Yes, you've mentioned this before, I think. Yeah.
There were a ton of financial institutions there, and so they got locked up as quants, and they made a buttload of money, of course. And I would have made the same decision probably. And we've definitely talked about that before, but I'm sure that, maybe they're just getting, locked away into like really, high-end jobs that you just don't meet them,
Yep. Please explain quants, for though that's a shorthand term.
What does it stand for?
Explain it.
It's like financial.
It's a quantitative analysis person,
right.
Like somebody, some like uber smart geek who runs the numbers, basically.
Yeah, or like creates algorithms for
and makes algorithms for stock trading and stuff like that.
Yeah, exactly.
Yeah. So, what's the financial equivalent? The insurance equivalent and actuary. Yep.
Yeah.
It's one of those uber smart math kids,
tables and stuff, right?
Is it? Oh, I don't know. I don't know about these. Yeah, but anyway, similar kind of thing. So, that's where they all must end up, because it's just, I swear, I've never met one.
Or they just, like, I'm sure they're out there. I think that's the thing.
Oh, I'm sure. Yeah. But I've just, it's always fascinated me. Why?
Yeah. Well, I think a lot of that stuff comes down to recruiting too. Like that is big, not big business, but it's a large, it's an important thing for both the school and for the companies, where they're like, we own, like I talked to some companies, they're like, we only go to MIT, or we only go, we go to these 5 schools, and it's, and
that's it.
Majority of the, they're able to pay the salaries that are, are tied to that kind of level of, school and stuff, but that's where they get all their talent from. So
No, it's weird.
Yeah.
I just expect like at least a few to sort of like dribble out into the community, but no.
Yeah. I think the thing that's always interesting too, I'm sure we've like we've been talking about, like I think we've talked about some of this stuff before and like how I got to go to MIT, but I went to like University of Michigan as well, which is, you know, good engineering school, and you know,
Right.
I went to a couple other. I went to Case, obviously, where it's my alma mater, and it's always amazing to me like the effect of brand on students, like literally just anecdotally looking at like the length of the line in front of companies, you know. And so you'd have like,
oh, of course,
so Keith, I was with Keith Lee, right? Not a lot of
not a lot of people lining up. Oh yeah, I've heard of an oscilloscope, you know.
Yeah, well, right.
Or sorry, I've heard of them, but you know, I've used a multimeter. Yeah, Keith Lee.
Right, exactly. Maybe they had a multimeter, but maybe not with, you know, source meter or whatever. But like, but all that stuff. But then like you go like and you see the Apple line, and it's, you know, around the block, and it's just like, yeah.
Or you know, SpaceX these days, or Tesla.
Oh sure,
something would have the line around the block, you know.
Right, and I think about, you know, young me, and of like same thing. Like I didn't know, and like I feel like there's some kind of room for resource here of just like, you know, it obviously it's on the student to go and, you know, research these things beforehand and blah 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 blah, all the things that career services do. But it would be a boon for our listeners that are younger to like, if you know of a company that's cool that hires students, and you know, like especially hiring out of school, it's tough, right? It's, you know, these days it's harder to get entry level jobs than it used to be, so it does come down to recruiting and stuff. But like understanding where these jobs are is important for that kind of, like where there's interesting problems that people that are accessible to cut rate talent like you and me, Dave.
Yeah, exactly. But it also comes down to the type of student as well. Like if you've just got regular Joe Blogg student who, I got the, you know, the SATs or the marks to get into engineering. So, you know, I'll just go into engineering because I don't know, my mate went into engineering, whatever. My parents want me to do it, you know, and the true hobbyists who know what they want. Right, because they will know who Keith Lee is. They'll know who, you know, Texas Instruments is. They'll know who National Semi is, or whoever.
Yeah, and then when they show up and they're like, "I've used a TI part at the TI booth," they're like, "Oh, hello,
hello, come on in."
Yeah, exactly. Yeah, exactly. I've seen that happen. You know, there was someone was posting. I'll have to see if I can find it. There was a student who posted on Reddit, and someone had mentioned contextual electronics, and that's the only reason I knew about the post. But it was basically like, I can't, you know, there's obviously, you know, we're still dealing with COVID stuff. A lot of internships are canceled. Jobs are, you know, disappearing and stuff like that. And so this person was like asking about like, what should I do instead? And, you know, it was some good advice. It was, you know, build projects and reach out and work on open source if you can. But mostly build stuff for yourself so that you can, when you do, you know, if you're not going to do an internship, build your own internship.
Yeah, do it yourself.
And especially because a lot of people are, at least in the US, are not traveling that much. It's like, use the time to, if you can, try and use the time to build something out and show it off later, like we always talk about on here. So
yeah, totally. So that segues nicely.
Does it? Okay.
Into a news article that I put on the Reddit, got a few thumbs up. And so, yes, many of the, I'd say probably most of the universities here in Australia, they could lose $16 billion.
Oh, yeah.
Because international students are locked out by the coronavirus. Of course, our borders are locked, you know, you can't come in. And that's 16 billion here in Australia. That's not Yankee bucks, right? That's, you know, 16. So 16 billion is a lot of money here in Australia, right?
It's a lot of money everywhere, actually, Dave.
Well, yeah, pretty much. But yeah, like these universities, of course, it's probably similar in the US, but probably not to the same extent as it is here in Australia. The Australian universities have built their entire, you know, like physically built their universities, built all these fantastic whiz-bang new buildings and everything else on the backs of, like, there's been massive growth in the last 20 years of the universities here in Australia. And it's all based on the back of full fee paying international students. And most of them are from China. Like the majority of them are Chinese students. We've got over 400. Our entire country has a population of 25 million, right? We have over 400,000 international students. Yeah. Right. Yeah. That is a massive percentage of that's a huge percentage of our population just in foreign students. And they're all full fee paying.
Well, that's the exact same thing here. Yeah, that is, there is,
right.
yeah, it's all full fee. And, you know, I know people that work in international offices and stuff, and it's a huge part of university businesses, and universities themselves are huge businesses as well.
Oh, of course, they're massive. You know, they get funding, and you know that's what, if you want to be a professor or a lecturer at a university, half your time is going to be spent, you know, trying to win grants and stuff like that. You know, trying to win grant money. So it's, you know, it's a huge thing.
Yeah, I agree. I don't know. Is that tied to the international thing though?
Oh no, I'm just saying in general. You know, like,
oh yeah, that's a big. Yeah, if you have a research focus, for sure. Yeah.
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 Half your time is spent finding money, let alone, and the other half is, you know, working on stuff. So yeah, just be prepared for that. I've heard that from many.
People yeah, one of my buddies is a researcher and you know, a professor, and he said him and a bunch of other professors were all on the same grant. It was 1,000-page grant. I was like, oh,
1,000-page grant,
1,000 pages.
Wow,
yeah,
wow,
it's crazy. Yeah,
that's insane. Yeah. How long did it take? Yeah, it might have taken them 6 months of work to actually write that grant so that they can get that money, so that they can spend the next 6 months working on it, and then they've got to go through the whole process again.
It's another Ferris wheel to step onto. You know, it's crazy.
Yeah. Wow.
Yeah. So the university thing is really interesting. Yeah. So my friend Sophie had sent me a Scott Galloway is someone who's been writing about universities and about like the coming death of a lot of universities, basically.
I've heard the name. Does he write a blog somewhere, or?
Yeah, so he's an NYU professor in the business school there.
Yeah.
And he also has a podcast, which is pretty good.
That's probably where I've heard him from.
Yeah. He's real sharp voice and very strong opinions. And basically what his argument is like, look, the high-end universities they're trophies, right? So you get a degree from a high-end university like a MIT or Stanford or whatever.
Yeah.
You're set, of course, but like basically they're so expensive and like they're so exclusive that it's almost not the reality for a lot of people out there. And then it was basically that like so much money, like you're talking about with the Australian universities, so much money is propping up a ton of schools that are out there that a lot of the, you know, second and third tier schools just aren't going to make it. And like thinking through the implications of that, especially with the U.S. debt, you know, student debt stuff. I'm sure some of our listeners have student debt.
Yeah.
You know, it's just like such a huge. I'm going to not do it justice, of course. So I do recommend people go and read some of his stuff.
It's a massive. It's one of your biggest problems there, apart from health and social security, welfare benefits, right? Yeah. It's like the third biggest.
It's one of the largest. Yeah, one of the largest debt sources. Past like mortgage, I think it may have outstripped mortgages and credit card debt.
Yeah, it might have. Yeah, it's huge. Yeah, I read the number a couple of months back, and it was like, oh, wow, you know.
Yeah,
couldn't believe it.
So Scott writes about all this stuff and just how a lot of third tier schools aren't going to make it, and yeah, it's pretty crazy to think about. Like,
what is the repercussion of them not? Oh, they'll shut down.
Like completely shut down. Yeah, he said that the median. I forget the number. I think it was like the median endowment of the 4,500 schools that are out there. So like endowment being like the chunk of money they use to fund the rest of the school was something like, it was in the tens of, it was less than $10 million. So basically it was like maybe like $7 million or something like that. Not enough to pay anything. Yeah. You'd either spend it or, you know, but basically that means that they're completely dependent upon people showing up.
That's a really small school. That's
yeah, well, and it's not. They weren't really small schools, so it was like basically the cash flow at these schools is just going to be trash. So I'm really interested. Obviously, you know, I have weird views on education, but I don't think that, you know, as much as I talk about contextual electronics as like an educational thing, I don't actually understand what the world looks like without a lot of the universities that are out there. And so like I'm very interested to see where it all goes. In a kind of morbid curiosity kind of way. I feel for everyone who's part of it though. It's like, you know, yeah, there's just a lot of shit going on right now. So yeah.
Wow.
So I do recommend people listen to the podcast, and he has a newsletter too. So
cool. Have to check it out. There is there's no talk here of universities going under, like, because we don't have that many. Like, you know, we aren't as you know, populous as the US. So anyway, there's no talk of them going under, but there's talk that look, because apparently like half the international students come in or start their course at the second half of the year, right? And we're right on the second half of the year here, and we're not letting anyone in the country for obvious reasons, right? So it's like that then not only delays it by 6 months, but then apparently they're talking about it actually has flow-on effects for several years. So just stopping 6 months of people coming in now has like 3-year flow-on effects. So
I mean, think about like research labs that are like, expecting people to be like part of the the machine that is grad students and postdocs and everything else. It's just crazy.
And it's not just the stopping of full fee paying students, not just the sudden drop to zero of full fee paying international students, although there's still some that are here, the ones that are here already are going to keep going. But there's massive numbers, like hundreds of thousands who can't get here. And so it's not just that, but on top of that, then there's the whole COVID economy, slowdown thing. Right. So therefore, like big companies are going to invest less, governments might invest less and things like that in, things like pure research and, other things. So, there's just going to be cutbacks there. So it's a double whammy. So, it's not looking good. Please, if you're at a if you're in the know at these unis here in Australia or in the US or in your country, please let us know in the comments. Down below, is there talk, like, are people, really scared witless that, their department or their project or their funding's going to vanish?
Well, hopefully not.
Yeah, it's a big deal, but I think it is going to happen. Like, I don't think there's any way out of it. Things are going to have to, some things are going to have to shut down. Hopefully not in entire schools, because imagine if you were halfway through. Imagine if you're halfway through your course and then your university, we just shut down. What the hell happens then,
Right.
And you spend all that money. Maybe you could transfer, perhaps. How is it over there? Do you guys have like a national framework? We've kind of got like a national framework here where if you if you're at one school, you can actually transfer to a different school because they're all on the same framework. No?
That is definitely not the case here. Yeah, no, I've had some friends who tried to transfer, and it's like you have to cross the courses, and you have to prove that it's this, because you think about it from a financial perspective. Like you're going to a new school, the new school doesn't want to be like, oh yeah, don't take any classes here. Just get the name on the degree. It's like, no, that's not. I mean, they're a business. Like a lot of them are private schools, and like they're a business, and okay, fine, it's up to them. But like, there's no. I think the state schools are probably more likely to accept other state schools
like that, right? Okay,
yeah, right. But it's like interstate system as well too. So like, the equivalent of like, New South Wales versus like Queensland or something like that.
Yeah. All right.
So
gotcha.
There's nothing. I as far as I know, there's nothing national. But I'm not that much in the know. So
okay, interesting.
Your mileage may vary.
Yep.
Yeah.
But there are national, once you get your degree though, I've done a video on this, which is, how you can go overseas and then your degree, if it's under the Washington Accord or it's under the Sydney Accord, these are different national accord. These are different global accord things. And like most universities sign up to these accords. And so if you've got your degree from one university in the US, you can come to Australia and it's officially recognized by the institute here because it's under the Washington Accord or something, So, yep. So that's
it's a weird business.
But,
like I wish there was a way to just prove that you actually knew the content instead of just, it's so hard to like actually do that. It's like, we could have a test or we could do, but at the end of the day, like I was literally, so I had a video thing over the weekend. I had to reset up my lab and I saw my college degree and I'm actually staring at it right now. And it says, the trustees have admitted Christopher John Gamble to the degree of Bachelor of Science Engineering. Like, who the hell is a trustee? Like, I don't care about them. Like literally it's like this, like, you've been inducted into this realm
this
of,
secret society.
I mean, like, I get it, but honestly, the name of the top's all I care about here, folks.
Right. Well, we've mentioned this before. It's like once you graduate, you quickly realize, maybe, it's going to vary from country to country, but certainly here in Australia, which course you did and which university, that goes to the very bottom of your resume. Right. Nobody cares. It's like nobody. It's like, can you do the job? They will test. And they'll ask you questions. They'll get the vibe. Show me projects you've worked on. You know what other companies have you worked for? It quickly becomes totally irrelevant.
And I would say, having looked at a lot of resumes as well, like even though it's somewhat transparent, I think that so say a young person is listening, like they're in college, they're like, oh man, I'm leaving school, I don't know what I'm going to do, you know, and or just that person who was taking advice online, right? They're struggling, they want to build something. I would say it's actually better to build a thing for yourself. Maybe you're going to do that anyways, right? You're going to build a thing to yourself. I think it's better to make up a name for your company and then say you're building it for your company and then list it under work experience. Now, it can be...
You could. And there's nothing, and you wouldn't be lying. So
I think you should be transparent about it. It's like, no, that's my company. I was building it for me or for this purpose or whatever it was. You should be very transparent about it. Maybe even make your company be your name.inc or not Inc. That's actually illegal. But like right. Your name Industries or something. Chris Gamble Industries or something like that. And like so, but be very transparent about that. But show it as work experience because it is.
Absolutely.
Assuming you're regulated about it. And I just think that that's better than being like, oh, and I built, it's not a hobby. It's like a thing that you're building because you should be building a thing.
And even then, like sell 5 of them. And then, you can say,
really is
yes, it literally is a commercial product.
Yeah.
Right.
Yeah. It is interesting. Like those small things that like push you over the edge. And it's like, oh, actually, I am a business. Okay. Yeah.
Just because you sold 5 of them on freaking Tindy or somewhere, right?
Yeah, that's great.
It doesn't matter. It's a commercial product.
Yeah.
Right.
I mean, people are making a living on there too. So like, it's not like,
yeah, of course. No,
it's more of a question of scale at that point, but yeah, I think it's, you're building a thing.
Yep.
Let me tell you about a thing I'm building, Dave.
Please.
And how I was a bit put off today. So I've been, this is actually the thing I've talked about on the show before. I'm building a thing for contextual electronics, and it's got an NRF 52840. And wouldn't you know it, there has been it's not a bugger, it's like a disclosure. I guess this is a disclosure, but basically someone announced recently that they can completely bypass all firmware protection on the NRF 52840.
Nice.
Like, oh, man.
Does this actually impact you though?
Not really. Well, that's a good question, right? So, this is a, it's a board I'm building for the course and for myself and as a development platform. And I think at a certain point, yes, of course it does, right? I'm designing a thing that it could go out in the world. It's, if it's a development platform, that means I'd have to redevelop it later. But like, it comes down to like, what is if it's a first spin, it's a first spin, right? I'm trying to get something out anyway, so I'm just going to keep going. But, it's like when do you make that decision? Do you throw away all the work you've done, or do you keep going with it and then you say, well, I'm going to change it later. I'm going to,
it's a project if it's a product critical feature, then obviously you have to take some action. If it's not, you go, meh, so what, like if it's just like a dev board or something, it's like, well, doesn't matter. Right. It's like, yes, you have to make people aware who are you going to use this dev board that, yes, this silicon has this, issue.
Yeah, exactly. And if it's a security forward application where it's like, oh, well, I need this to be a secure product, that's probably not the right dev board for you. It's probably not the right part for you.
Oh, yes. If you're using that part for like some sort of crypto hardware wallet,
exactly.
It's you're going to come a gutser. So.
Right. But you might not want to put Bluetooth on it in the first place then.
Right, yeah, of course. What is the mechanism? Is it like a side channel? Is it a power rail side channel attack?
Yeah,
right,
side channel. Yeah.
Side channel.
And so, I was talking to Colin O'Flynn actually the other day, and
who has developed the
he's been on the show before, and he does the chip whisperer and the
chip whisperer,
chip shouter and stuff like that.
Yep.
I still don't quite understand how it works, to be completely honest. I kind of get it. Yeah. It's
it allows you to do methodical side channel so power. You can monitor the power and going in and out, and you can modulate things, and you can.
Yep. Yeah, and I think there's some fuzzing here as well. But basically, at the end of the day, what happens is you can then go and dump you get debugger control on this chip using these methods that
and then bam, once you got debugger control, you've got you can dump out all the code.
You could do more than just dump it though. I think if you have debugger.
Oh, really?
So
okay. Yeah. Oh yeah, no, of course. Well, a debugger is a debugger. You can change registers on the fly. You can, do all that sort of jazz. So yeah.
So yeah, it's interesting. It's interesting from a well, I mean, it's not like I'm not the problem here, right? This is like the NRF 52840 is like, it's out in the world, man. There are a lot of products out there. This is not a small part. So that's a much
how did you
deal.
find this? How did you did somebody tweet it to? Oh, right, hacking you. All right, okay. Yep. And you went, I'm using that. Oops.
Yeah, I mean, well, it's just an interesting, there's always the voyeurness of like seeing an interesting hack, right? That's always interesting.
Yeah.
But it just happened to be the chip that I was using. Yeah. So it's not like I got like an email from. Yeah.
But it's like shoulder shrug these days. It's, there's another chip that you can bypass with side channel attack. It's like if that thing really matters for your product, you're going to spend a month doing your research on which is the best device to choose. It's like, and for reasons, it might have physical hardware protection in there that prevents side channel attack. It's got physical hardware protection in there over the die that actually prevents decapping and then laser, reading out of the ROM contents and, all that sort of jazz. So, it's like if you want an ultra secure device, you probably wouldn't be using something with, as you said,
have security in the name or something like that.
Interface.
Yeah.
It's
Yeah, you're right.
Yeah. No, there are specific devices on the market.
I just thought it was interesting because I am, mid-design. Like I don't think. Yeah. I don't know. Have you ever had that where you had like a design and it like went obsolete or anything like that too? Like I've just never had. I've had actually one thing where the connector went obsolete.
I haven't worked on consumery enough products for it to be a problem. Let's put it that way.
So we
have gone into production for knowing that part is obsolete, right? And we couldn't be bothered changing it because we're only going to manufacture 100 of these things, 1,000. Like
you buy a tray or two and you're good to go. You're saying,
and you're good to go. You're good to go because like we're in that business. We would have a 5-year contract for a project to supply the military or some other company, right? And then you just buy the parts up front. Bingo! I've got my entire. You're contracted to produce 10,000 of these widgets. You buy 10,000 of the chips and you're sweet. It's like who cares if it went obsolete? Doesn't matter.
Buy insurance.
You'll actually cover that down the road. Well, you can deal with that down the road, and we've discussed component obsolescence, and you've done that in your job, haven't you? Component obsolescence engineer. And So you would deal with that down the road. You would, often there'd be like a pin compatible part. You'd drop it in and you'd recompile or something, or some other thing. At worst case, you would have to relay out your board. If you didn't want to touch the board, you wanted to modify existing products, you would do a mod board. I've done videos on how to do mod boards and things like that.
That was relatively recent, right? That was like a Flex PCB or something.
That was a Flex PCB one, but I've done other videos as well on actual mod boards of making mod boards. Which, if you don't know what
I've done that before.
If those who don't know what a mod board is, I'll quickly go over it. It's where you've got an existing product, you've shipped, or you've already got, 10,000 blank boards, right? And they're really expensive boards. They're like, 10 layer and they cost, $100 a board or something. And they're giant things. And you don't want to, you've already made the investment in those boards. You don't want to respin them, right? Because it's really expensive. It's going to come as a shock to people, but not everyone makes little Arduino sized, 4-layer boards that cost, a couple of bucks, right?
I mean, you're making a 4-layer board for an Arduino, Dave. Come on, don't be too fancy here.
Too fancy, right? No, some boards cost hundreds or $1,000 a pop, right? For a one-off blank board. Right, because they're 16 layers and they've got micro vias and they're got
just the amount of time and the process that was put into,
and they're physically large,
slapping that thing together,
exactly. And they they got so many, and they got Rogers controlled impedance material and they got everything else, right? Really expensive stuff. So you don't want to respin that. You can't respin those boards. You can't dump them.
Well, you can. So you need.
Well, you can, but it's expensive, right? It's just, no. Yeah. So you decide, no, it's cheaper. You know, you've got 1,000 of these things. It's cheaper to make a little adapter. Mod board's a little adapter board that basically goes over the existing footprint. It depends on the physical implementation of the thing you're trying to, say you've got a quad flat pack chip or something, right, that you want to actually replace, then you would get a board that actually fits that footprint. So that, and then it would have half moon castellated edges on the side of the board, right? That would actually line up with the pads, and then you'd put another chip on top of that, for example, and that's a mod board where it'll solder in. You might have to hand solder it, for example, but hey, you know,
but you're only making 100
trade-off.
Or 10
yeah,
whatever,
doesn't matter, right? So then you solder that board in to actually physically replace the chip that you want to do. And then you can get more fancy using flex circuits. If you need to connect this point of the circuit over here to somewhere over the board, you can make this big flex, you know, overlay kind of thing that joins up the two things, so you don't have to do mod wires and stuff like that. It's just neater. But anyway, that's and that's a thing you'll often have to do in the engineering world, is a mod board. Very common. So
and very annoying. Very annoying.
Oh no, I actually enjoy. I really. Oh, you want me to do a mod? Oh, I've got to do a mod board. It's really nice to be able to figure out how to actually do it nicely. You know, as you know, I actually enjoy the process. Call me a sick puppy, but I actually rather enjoy it. Yay! I got to build a mod board rather than just relay out. I don't want to rip up the board. I'd rather have the engineering challenge of making a mod board. I really enjoy it.
All right. Well,
yes, I'm weird. Sue me.
You do you, buddy. You do you.
Anyway, that's that. What else do we want to get on? Oh, yeah. I just I retweeted this one because this is an Adafruit post, and this is interesting. Yeah. A Type C USB, because USB is always bloody changing, isn't it? And once
I do wonder past this
what the next
Type
USB
C. Yeah.
Anyway, USB Type C. USB Type C is how it's got all these new power delivery stuff. It's got these two lines in there. It's got the CC lines, CC1 and CC2 lines. There are extra lines on the USB connector that allow you, I2C type lines that allow you to actually communicate between the the host and the device how much power you need. So if you plug in a power, if you plug in one of those portable battery packs and you want to fast charge it, right? It needs to send data to the charger to say, hey, I'm a smart device. I can handle. Please give me
all you got.
20 volts at 5 amps. Yeah. Please give me 100 watts. Right.
Yeah.
And which I think is close to the maximum for USB.
That is the max.
Yeah. Close enough. Yeah. 5 volts, and so you can change the voltage. So USB-C is capable of the power delivery standard is capable of. It's not just 5 volts. It's capable of going up to other voltages, right? And currents. So you've got to negotiate that smartly. And some products, like I said, a USB power bank or something, right, or some other thing that you just want the power. That's it. You're using the USB-C connector just for the power. That's it. You don't need to send data. Yep, give me the juice. But you still need to negotiate that. So rather than using a pain in the ass a regular USB-C connector that has how many pins on a regular USB-C connector and how tiny a pitch are they? They're just a pain.
20 plus, I think. Yeah. 24 pins. Yep.
Absolute nightmare, right? Really mongrel parts, pain in the ass thing of the week, right? Pain in the ass component of the week. Is that an acronym?
No.
Anyway, no. Anyway, so rather than do that, CUI, who's a connector manufacturer, they've just released one, which is for those playing along at home, the UJC HP3 SMT. Mm-hmm. It's the connector of the week, and it only has the power pins and the 2 CC lines. I think it's got 6 pins and a 1 millimeter ping pitch. Beauty.
Yeah.
Geez, 1 millimeter. Geez, you could, drive a truck through 1 millimeter. Unbelievable. So, nice. It's just a connector dedicated to just that. So, I think it's fantastic. Yeah.
Yeah, I mean, it's better than some of these other connectors you posted about on Twitter. What about these other?
Yes, I forgot about those. Yep. Yeah. They're yes, I did put those on the Reddit, didn't I?
Yeah. There's orthogonal, advanced orthogonal interconnects and similar out of this world military style connectors.
That one actually got almost the most thumbs up, I think. Yes, people were, so let's talk about that. People wanted to talk about these connectors. Phone FOON on Twitter posted these, so I retweeted those. And advanced orthogonal interconnect is a pin grid array right angle adapter.
I've never seen anything like this. So
you haven't? Oh yeah, no, these are.
It's kind of hard to explain, but what is this even for? So it looks like.
What it's for is if you've got you're designing your product and it's got this advanced processor on it, right? Which is a big pin grid array thing, not this not this BGA rubbish, right? Like it looks like a pin grid array, so it's like 50
it actually plugs like the old Motorola connectors you're talking about, like the ones where the pins are on the edges and stuff like that, and they plug into like a huge socket or something.
No way, like the old school 486 processors that they actually came with pins, right? Yeah, exactly, those, right? Yeah, so those, right? So if you've designed your board, you've laid out your board, and then you want to troubleshoot it, this is like advanced, high end tools. You want to put your logic analyzer around there, your debugger, and all that sort of stuff for this advanced processor or FPGA or something, right? And you want to probe it in real time, then you get one of these adapters, you either plug it in or solder it into your board, and then it brings out all the pins at right angles via controlled impedance tracers, right? And, so it's all, these things probably, these things are really expensive. Right? I don't know how much this one would cost, but, you can spend hundreds of dollars, start at hundreds of dollars for one of these adapters, orthogonal interconnects, sorry. And they just bring out all the pins so that you can plug your chip into the outside and then you can probe. You get access to proby pins. Although this one's a bit weird. It's got like large copper internal things in some triangular wedge shape thing. So it's really this one's a bit bizarre, but the general concept is you're breaking out. It's basically a breakout board.
Yeah. Okay. So it's not actually like a practice, and like people, like we said, it's tough to say it in words. Obviously, we'll have links to Foon's Twitter account and stuff like that.
Although technically, this one, I think it is physically a connector. I think it is a connector. It's a right angle connector, effectively. I think it is. Okay. That's what those large copper. You got to see the photo. Those large copper flat pads in the middle, in the X shape in the middle are. I think they're large power pins. And then all the others on the other pins on the outside are, like just regular pins, right? Mind you, they're controlled impedance because it looks like controlled impedance traces. I can see that they've got the little squiggles in there, so they're matching the length, right? They're matching the length of the traces there. So, so it's high speed, obviously. But so anyway, so I got sidetracked there. This one's probably some sort of weird ass right angle PCB connector, I think, rather than a breakout, which was what I was talking about. But I've seen these identical things. As
the whole
breakouts.
Thread is just like, it's weird, mechanicalness and probably military connectors and stuff.
Yeah, this was the industry I was in.
Right. I was going to ask about that.
Right. Yeah, we needed, right? The example, this one that has all these Ethernets, got 2, 4, 6, 8 Ethernet pairs in the one military connector. You can tell it's like military type because they all have the same drab or olive. I think it's officially called drab olive, or semi-officially called drab olive finish. Like, actual color. It's a similar, Yeah,
it's that military fatigue style. Yeah.
Yeah, kind of thing. If you've ever seen the military stuff, they're all the same drab olive color. Anyway, so rather than, you could have just used Ethernet connectors. You could have just used 8 regular Ethernet interconnects. But then, you've got 8 separate cables, right? So you've got to plug them in, and you can plug them in the wrong way. This is designed for like aircraft and tanks and vehicles and other industrial machinery, where you have to disconnect stuff for maintenance and testing and replacement and things like that, and plug them back together and get the plane or whatever back in the sky, right? But you don't want to have run any risk of plugging the wrong thing in to the wrong place when you reconnect it back in. Right? It's not just the robust nature of these military connectors. It's also for the fact that you can't goof it up.
Right. So, I was just thinking as I'm like scrolling down this list, and I'm like thinking, these connectors are terrible to look at, but you know what? You should see
they're gorgeous. What do you mean?
No, you should see the friggin' cable diagram for these things. Just like the amount of some of these things have hundreds of pins attached to them. And it's like, you gotta have a drawing for each and every pin, Ethernet, you get it. It's like a bunch of pairs, but like, when it's 100 individual pins, and they gotta go somewhere.
Dude, try soldering connectors like this. I've spent countless hundreds of hours soldering connectors like these. And when you're, it'd take you an hour or 2 hours to terminate one of these connectors. Right.
Yeah, I believe it. Yeah.
And hours to terminate. And then just before you put in the last one, you realize, I'm using the wrong diagram. No, well, A, you forgot the heat shrink, or B, you're using the mirrored diagram. You're using the front face diagram instead of the rear face diagram. Oh my God. Like, this happens so many times in our business. We had to come up with.
Why do we even have this? Why is the other drawing even a thing?
We would have to have like large color coded fonts in like 200-point font on there. Permanent marker saying backside diagram. Like it had to be in your face. Otherwise, you'd accidentally, if it was just down in the info box in the bottom corner, right, you'd get the wrong one.
Oh, yeah.
Right. Totally. And then you waste hours just soldering in them all mirror image. And then you've got to desolder them all, and you've got to start again. You have no idea how many times this happened. It's just,
well,
oh my God.
Intelligence versus perseverance, Dave.
Perseverance. Right. Sometimes you're just having a bad day and Murphy's going to get you.
Exactly. So, sometimes you're having a bad day, and you know what? You screwed it up. You got to do it again. No amount of saying how smart you were allows you to just swap the connector around.
Exactly. No amount of, anyway. So these connectors are very common. These custom, like we'd have ones with mixed twisted pairs. We'd have ones like that had twisted pairs, power, optical in the same connector. Giant, like everything, all in the optical and mechanical and pins all mixed in the same connector.
How would that work? Would you have to like crimp the optical first or something, or how would you actually?
You would terminate the opticals. Usually went in last. You'd terminate the others, and then you'd leave room to slip in the opticals. But you had to you had to polish the optical connectors, and then you'd have to terminate the optical connectors, and there's special machines to terminate those. And
would the termination like be built into the connector though, or would it be like, and then like, or you do it externally and then plug it in?
You do it externally and then plug it in. So you would, and the connector would be physically designed so that when you plug it in, there's like a latching thing, and it'd keep it at the right distance. And usually they're spring loaded. So when the optical things are spring loaded, so that when the two connectors join and you screw them together, they actually touch before it gets to the end stop. And then when you tighten it up, it applies a little bit of pressure to the two optical ferrules, and then they line up. Otherwise, you can't just rely on the fact that they're just going to mate. Like half a millimeter. Like no, you want the springiness to. Anyway, companies like Amphenol, for example, they're one of the biggest in the industry. They have entire departments dedicated to designing these custom connectors for you. So you go to them and say, they will make any connector you want to any specification. It's absolutely amazing what these companies can do. Right. And
technically, Dave, if you have enough money, a lot of companies will do whatever you want.
Will do whatever you want. Yeah, exactly.
Right. Give us enough time and a good enough spec sheet. We'll try and build it for you.
Yeah.
Okay, right. I guess.
You can go to them and say, okay, I need 200 of these special connectors, right? Yes. Which have 50 pins and optical and Ethernets and everything in there, right? And all these high speed and all these, because they've got all these different technologies that they can wham into the one connector, and you can mix and match anything.
I'm just remembering back to like previous shows where you say, oh, we have to make everything custom. You were talking about the microsupply. Everything has to be custom. And I was thinking about these kind of exact conversations where someone says, we have to be custom. And then you start talking about 50 connectors at a time. It's just like, man, it's a sickness. It's like,
but sometimes you have legitimate
some have requirements.
reasons.
So, I get it, but
so these companies where you can go to them and say, I want 200 of these connectors, and they'll happily make it for you, and they'll charge you $500 per connector. There's no problems whatsoever. At minimum, right? Yeah. But it solves a niche problem that you need, and you just pass that cost on to the customer. It's when you're in that sort of industry where one product costs $50,000, it doesn't matter that you use a $200 connector on it. Right. It makes absolutely, it's if it does the job you need. And
right. Or if it's going to save water damage down the road or whatever. Sometimes you just got to have it.
Waterproof connectors. There's because I was in the marine seismic business. Yes. Waterproof connectors on top of this, on top of this, we'd have waterproof as well. It's absolute double O-ring, by the way, and they have to be greased up, by the way. If you don't grease up your O-rings, it's not waterproof.
You got to grease up your O-rings, folks.
Yep. Got to get the right pressure. There's all the mechanical engineers out there are salivating at the thought of actually designing an O-ring properly.
Yeah, everybody is a fan of this design until they have to spend 200 hours analyzing if any water has ingressed into anything in a submersion tank or whatever.
I also have a fascinating video that touches on this. Rodney Redwin from Simulator Solutions. I've done those 747 flight simulator videos, and he takes us through a 747 cockpit and shows us some of these custom connectors. And a lot of them, even though they're identical connectors, you can actually get them keyed differently, so that literally you can, even though they're the same connector, they're keyed. They're keyed around the outside, so you cannot plug in the wrong one into the wrong thing. So, yep.
Which
and
is good.
That's pretty important in an aircraft if you're, because these aircraft have to be checked and maintained and, repaired and, they on a regular basis. You can't just, use the same connector for everything without keying. It's like, geez, no.
Well, you can at your own detriment, I think.
Well, exactly. Anyway. Custom connectors. I love custom connectors. They're great. Anyway, very exciting. I've a large part of my career has involved custom connectors. So, and testing them. When you get the connectors, then you'd have to design and build a jig, which in an insertion jig. So that you can physically mate them and insert them. And the screw-on ones are different. Sometimes you just have to got to do it by hand. So you got to do your 1,000. 1,000 insertions.
No strong forearms,
Yeah. So anyway, great stuff. Love it.
Well, what else is on the list? Let's see. Alan, former guest of the show, Alan, did a wonder. This was a really great video. I wish I would have had this before I bought my VNA.
And it's going to be a series. I think he's mentioned that it's going to be a series. So yes.
He's going to be doing a lot of basics. If he's listening, I kind of hope it's not because of me, but if it is, I probably could have used this. But anyways, the really cool thing about it, so the thing that I didn't quite understand, I understood kind of the basics of it, but I really like that he shows how a VNA works in theory. And basically he's passing a signal out. What a VNA is effectively is you're passing an AC signal out, or, a sine wave effectively at different frequencies. And then you're seeing how it bounces back, just like reflections on, a PCB trace or any other, matched impedance type of thing. And that's what you're basically testing. And so he puts
that's because everything's a transmission line, folks.
That's right. Yeah. And so he shows how it actually reflects, and then how the actual wave shows up on a scope then. So he's looking in the time domain, of course, but
right.
But yeah, it's just really, really good. So
yep. And then you have to get into ports. You've got to get into multi-ports and things like that. That's and then you have to get into your S. You have to get into your S parameters and your all sorts of other stuff, joyful stuff. Which that's not my field.
Yeah, I'm trying to make it my field. It's been a challenge, I have to say.
Yeah.
I've really been. So I've been like I mentioned 2 weeks ago. I've been working on mine, and Mr. Jeff Kaiser has been helping with some stuff. And what it really comes down to is just like there's no way to know like the reference point of like what's good, like so especially because I'm a beginner and like and like you have a calibration kit and you have to like understand if it's right and anything will show as it's being calibrated, right? So you put these, you put an open, you put a short, and you put a load on there, 50 ohm load, and then basically it calculates all these coefficients and it does all the math to make it look like a flat line when it's open, and when it's on a Smith chart, it's like right in the middle, it's 50 ohms and everything looks great. But then like lately I've been like looking at it, I'm like, I put a cable on that and it's like, oh, this cable is emitting RF energy somehow. It's like, nope, that's not right. That's not how that works. So it's just, knowing, kind of like these, it's not really mantras, but it's just like these kind of higher level ideas of what can and can't happen, like on a Smith chart, right? You can't be outside a Smith chart or else you're usually emitting energy and stuff like that. And it's been very, very enlightening and frustrating together.
And that reminds me of speaking about VNAs and calibration and connectors, tie them all together. Oh,
wow.
Winner, chicken dinner. Is that, that reminds me of when I went to the Keysight Cal Lab, and I've done videos on this, and they were talking about, when you're talking about like high calibrating, high frequency RF stuff, right?
Yeah.
The torque on the connector matters. Right, you have to use a torquing tool on these connectors, and if you don't get the right torque, your calibration is not valid because you're going to be out by a dB or two, because you torqued it wrong, right? When you're talking about a 10 gigahertz being a specialized, SMA connector or something, right, working at 10 gig on some scope or 20 gig.
No, don't do SMA for 10 gig. That's bad.
Oh, well, right? Well, no.
Yeah, right. Whatever the special. How about, APC7, which I've learned is a connector, because that's when my VNA showed up and I'm like, what is this connector on the front? I don't know how to actually interface with this. It's very, very
And that's
annoying.
why you can buy $500 for a connector.
Right? Or a converter. Yeah, that's what I did. Yeah,
I paid for a converter, right? Because it's got the
APC7 to 3.5 millimeter is the $500 worth of metal. It's a hell of an industry, Dave. Let me tell you.
$500 for a 50 ohm terminator. Thank you very much. $1,000 for a 50 ohm terminator, right? And you can literally ruin them if you don't torque them up properly. And these high end scopes, if you're talking, your 20 gig, your 50 gig, your 100 gig scopes, those connectors, if you abuse those, you've just screwed your scope, right? I'm sure you could get them refurb for a couple thousand.
You could probably
anyway
send it in for service.
So I've done videos on that if those want to know about the the intricacies of RF connectors and stuff like that. It's absolutely fascinating. How, really like most engineers probably would never care about that sort of, you would never know nor care about that sort of thing, because you're working on your digitally Arduino-y, Raspberry Pi
thing that's
widget,
less than 10 megahertz and you're happy, Right. I used to be there, Dave. I used to be less than a gigahertz. Those were the days.
No, I'm just not, RF's not my thing.
It's interesting. I mean, like, I would. I mean, if you're open, it's I think it's tough for you because like, you're often learning in public, and that's tough because you have a big presence with that. And it's like, but it has been, it has been a re-education. It has been a humbling experience. Like just like how many things I don't know about it. Like, and obviously there's a lot of people that like this is their life and their job, and like I really respect it. Like the that kind of knowledge. Yeah. And that's why, some RF consultants charge $400 an hour, of course.
Of course.
Like for them,
like there's no way I could go out and use a VNA without a refresher course like this. I just wouldn't be able to do it. You could give me a DSA, like I'm used to using a dynamic signal analyzer, which, is like 20 kilohertz was high frequency. you know.
Oh, right. So that's like a network analyzer for like an audio circuit or something.
Yeah, exactly. So, but it's a similar sort of thing, you know. And,
it is, yeah. We used to use that for control loops at Keithley, like to test like how it's propagated, you know, like if you got a oscillation or something. It's great.
So I could tell you all about coherence and, you know, signal coherence on DSAs and stuff like that. You know, that was my bread and butter. But
got it.
Put me in front of a VNA and go, well, okay, you know, measure this connector and transmission line. I'm going to go, oh, geez, no, you know, I could bumble around and, you know, maybe get something up, but I really wouldn't know the intricacies of it. That's stuff that I just never been into.
Well, if you need someone to call, I can refer you. Yes, sir. So, yeah.
Anyway, this will be a great series. Yeah. VNA series.
So if you have questions like Dave and you want to ask us something, probably not about VNAs, Dave, who can they call? Who can they
Ghostbusters?
Who can they
Jason Reitman.
No.
Oh, come on.
It's us, Dave.
All right. Yeah.
They can call us. So we are going to do a call-in show for the 500th episode of the Amp Hour. We're going to take some questions at least. We're probably going to talk about other stuff too.
Oh yeah.
But that is
probably. Yep.
This is 496. We are racing towards it. So
yep.
Early July.
So we'll do that. So we still haven't decided what. Probably like email. Like you can always email in your MP3 with your question. Say hi, I'm such and such from such and such. If you want to, you don't have to identify yourself. You can just ask your question. You know.
Sure.
But it has to be in voice form.
It's a lot easier if we can mention, you know, at least a screen name. You know, like. And so, you know, Scope Lover 123 is called in about blah, blah, blah. Right. Yeah, I mean, like, yeah.
Got it. The interwebs. Yep.
Yeah.
It's great. So, yes, we'll try and do that. We have had a call-in show. We did try it like donkeys years ago, didn't we? We did multiple. We did multiples. We did like 4 or 5 call-in shows. Did we?
Dave, yeah.
Oh, really? Okay. Well.
Yeah, we stopped doing them because people stopped calling,
right.
And so
the novelty wore off.
Yeah, I think some of it's that. I think some people are like listen. So this is going to be a couple shows out. So you need to get us a thing by July 6th. So you need to get your questions to us by July 6th. We will have a link to what was the online? Oh, here it is. online-voice-recorder.com. Basically, if you don't have any other way to record a voice, use that, download it, send it to us, or send us a link to it on Dropbox or Drive or whatever.
Oh, it'll be a small file anyway. It'll be tiny.
Yeah, if we come up with something better, it would be. Yeah, we'll tell you about it in the future. But yeah, if you're interested in asking us a question, we'd love to try and answer it on air. There will be, if you are in the U.S. time zone, we can maybe, let us know if you're interested in maybe. If the timing syncs up, we'll maybe have 1 or 2 live calls on here, but probably not.
That's
live,
kind of tricky.
Quote, unquote, live.
That kind of, yeah. Mm.
But yeah, the easiest way to do it, of course, is to send us a voice question. So I'll have links about it. I'll have details in the show notes. What you should
How many people can you have join a Zencaster thing? How many channels?
I had 5 so far.
5, okay. All right.
So we could maybe do that.
Yep. So we could have several people join. We could have multiple people join, and then we could mute them until we're ready to ask a question, can't we?
That's right. Yep. And they would be able to hear everything, but
they would be able to hear the show live. Yeah.
Yeah. And, just like the real radio, Dave. It's like the real radio.
Woo.
Yeah.
Yep.
1960s technology. Here we come.
Yep. But you've got to have real buttons. You've got to have like buttons on a desk.
Yeah.
None of this mouse rubbish.
Next caller. Hello, you're on the air.
You're talking to Dr. Phil. Yeah.
Click and clack might have been a little bit more, fun and nerdy, but yeah. I don't even think Click and Clack actually did it live, so whatever.
So tell us about your problems with your oscilloscope and how it relates to your mother. And your childhood trauma,
The Amp Hour After Dark.
Oh boy. Anyway, yep. Our Amp Hour's up, dude.
It totally
Let's
is.
get out of here.
Okay.
Catch you next time.